So as we just saw earlier, you just take these cash flows and discount them compared to the year in which they are related. So 20 million discounted by 1 year. Here you just take 20 million of 1 plus R equals to 10%, which is 0.1, then power 1. For year 2, it would be 1 plus 0.1 power 2, and year 3 it would be 1 plus 0.1 power 3. And then you sum up your cash flows. Summing them up, you arrive at this figure here. And then everything will be all right. That would be the present value. But the question actually included another portion here. We are told that also compute the future value at the end of year 3 if the relevant discount rate is 10%. So we just need the future value at the end of year 3. So from this point here, we already have the present value as this figure here, and we need the future value at the end of year 3. So if we just need the future value and we have the present value, we know the formula. Future value equals to present value times 1 plus R power n. So you have a present value here, 50,112,697 times 1 plus R, which is 0.1 power 3, ending up with this figure here, 66,700,000. So that's how you go about a question like this. We are done with multiple cash flows, and all we have remained with here is annuity, perpetuity, as well as growing annuity and the growing perpetuity. Actually, if you finish up these annuities and perpetuities, you have gone a much further step. So let's go to annuity, another form of cash flow. What is an annuity actually? An annuity actually is just a multiple cash flow, but the only difference is that the annuity is fixed. If you receive $100,000 each year, it will be the same, it won't change. That's what we call an annuity. So an annuity actually has 3 things. You have to know those 3 things about the annuity. All right? The annuity, first, it has a constant amount. The annuity, equal spacing. They have equal spacing between equal period. Equal period spaces. But also when speaking of an annuity, we are told the annuity that occurs for a given period of time, You cannot, if you receive $100,000 at the end of each year to infinity, that's not an annuity. That is a perpetuity. Let's say that you are going to receive $100,000 million at the end of each year, given period of time. Let's say you receive it for 10 years, for 10 whole years. If you do something like this, it's something we call an annuity. It's constant, it's receivable or payable in equal period spaces, and it's received for the given period of time. If no given period of time, if you just receive it infinitely, that's the perpetuity, not an annuity. So you have to understand that very, very clearly. So that's why if you speak of an annuity, we say that it's a series of equal amounts. Now observe those 3 points. Equal amounts occurring at fixed intervals, equal spacing, and for a specific period of time. If not for a specific period of time, we call it perpetuity. Actually, we'll see it. So simply speaking, an annuity can come in different forms based on when it starts. For example, let's say you need to pay rent to the landlord. Actually, the landlords actually need to be paid in advance. If you pay, maybe if you need to pay the amount at the beginning of each year, it's the landlord, so you pay at the beginning of each year. But also there are things that you receive or pay at the end of the period. So if something is payable or receivable at the end of the period, we call it ordinary annuity. But if something is payable or receivable at the beginning of the period, We call it annuity due. Annuity due, that means a payment is made in advance before the actual activity starts. Actually, we'll see the relationship between the two forms of annuity. So ordinary annuity, we are told that the amount is payable or receivable at the end of each period. And how do you obtain the present value of ordinary annuity now? The present value of ordinary annuity is just obtained this way. You just take your annuity, this A is the amount that is payable or receivable at the end of each period. You multiply it by this factor. This factor here is called the ordinary annuity factor. 1 minus 1 plus r power negative n over r. Actually, I will explain to you how this factor is arrived at, but you just better understand it because there is no way you can avoid it. Actually, I know most of the people don't like mathematics, but this comes from the topic of mathematics called sequence and series. And it is in the geometric progression, but you don't need to know that much. All I need to tell you here is that why do we use this formula? Why use this formula instead of just taking cash flows in the normal way? Let me show you one thing. Let's go to the previous example so that I can illustrate to you more. Look at this question here. You see, we are told at the end of year 1, we have a cash flow of 20 million, then 25 million, and then 15 million. 20, 25, and 15. Now, suppose we are to receive 20 million at the end of year 1, 20 million again at the end of year 2, and 20 million again at the end of year 3. This would have been the ordinary annuity. We would have there would be no need to use this formula here. We could have just gone to that formula above directly to reach at our solution. I hope you get me now. So that's the main reason we prepare that formula. We have for 10 minutes and everything will be all right. Let's just complete. So this is the formula of ordinary annuity, present value of ordinary annuity, and if you need to know the future value of ordinary annuity, this is just very direct. We know that the future value equals to present value times 1 plus r power n. So no need to know this formula here. No need to know this one. This single formula here above is very sufficient. You have the present value. If you need its future value, you just take the present value, you multiply it by 1 plus r power n. Of course, if you multiply this by this figure here, you will arrive at this one. But actually, there is no need for that. So you could just end up knowing the formula for present value of ordinary annuity. And then you have something called annuity due. What's an annuity due? An annuity due, as I told you earlier, the amount is payable or receivable at the beginning of the period. So ordinary annuity at the end of the period, annuity due at the beginning of the period. So if the amount is paid at the beginning of the period, that means annuity due has a much higher value, has a much higher weight compared to the ordinary annuity. So you just need to know the relationship between annuity due and ordinary annuity. So if you are told this is the annuity due, you just say that annuity due equals to present value of ordinary annuity times 1 plus r, just like that. You repeat the same formulas above, but we just multiply them by 1 plus r. You just need to know how you arrive at these figures. You don't have to know each and every formula. You don't do it that way. I hope this is just fine. So the same, if you need to know the future value of what annuity due, you can just take the future value of ordinary annuity and multiply it by 1 plus r, the same thing, and you arrive at the answer. Now we go to perpetuity. Perpetuity, actually, I don't need to go directly to this perpetuity. Let's go and take a look first at an example. So as to see how the annuity is computed. Let's go to example 6. I think this example is fine. Now we are told that an MPLC, example 6, an MPLC has just entered into a contract that will provide it with 5 million at the end of each year for the next 5 years. A discount rate of 11% is used. Required now. Required, what are all the receipts worth now? What are all the receipts worth now? How do we go about this? What are all the receipts worth now? That means they need the present value. Now look, an NPLC has just entered into a contract that will provide it with 5 million. The amount is 5 million and it will be obtained at the end of each year. The end of each year means ordinary annuity, not the beginning. The end of each year for the next 5 years. That means at the end of year 1, you receive 5 million. At the end of year 2, 5 million again. The end of year 3, another 5 million. You go that way and all right. I think this